In this lecture, we will see how we can generate images from the data set we get and steer the generation towards the class we want. So in this is what we call as class condition diffusion model. So for example, ImageNet is a data set which has huge number of categories. So there is 21,000 categories could also be there. Let's check ImageNet. And however many categories there are, if you check, it's like 14 million images and I think 21,000 some word syntax or something. So huge data set. So when we have ability to generate images based on a specific class which is part of that thing, we have a very fine-grained control, and we have a amazing model which gives us the images of that specific concept. So for example, car, a dog, a specific breed of a dog. So this is very fine-grained info. That's why this class condition diffusion model is so great. Diffusion model is, again, if you think about it, what it does is it takes images as is and learns to generate images by using those images only. In other words, the data set doesn't need any human to annotate. So all the images on social media or internet, as long as they are downloadable, you can just use this model to learn on them. So what it learns to create images based on all the things it has already seen. And better control you have on the output of that model, better your model is. So, like Midjourney, if you want to reach that level of a very good product, this is how you keep increasing your abilities of your image generation model. So, until now, we saw a simple model pipeline and we fine trained it. Then we were put saying guidance and conditioning, and now class conditioning. So, as a continuation of this thing, the final part will be image generation like Mid-Journey or Stable Diffusion. So let's check the code for today's course. Hugging Face image generation for class condition image generation. I should have already ran the code, but I forgot. So just read the code with me. Yeah, sorry. So imports, these are the same imports as we have had in all the slides. Okay. Then we are downloading dataset. Check Torch Vision datasets MNIST. So we are downloading handwritten digits, a very small data set, but we are downloading because it makes the training and downloading easier. If you go on Hugging Face and try downloading ImageNet dataset. So for all computer vision, we all know the classic OG dataset for where everything all started was ImageNet. And even downloading that most common data set took me 2 3 days. It's huge, 6 hours of uninterrupted download it requires, and my internet connection and some problems. It was annoying to download it, and that is one of the smallest data sets, smallest real life data sets. We only have more data sets from there. So that is why we always choose a very small one. But as long as we are on a final model, we just scale it to whatever size of data set we are on. So get the data set, get the data, and blah blah blah. And then what do we do? Diffusion models, everything we have done until now. Diffusers is the Hugging Face library. Diffusers. We do two things. We get the pipeline and we get the scheduler, right? So here we do scheduler first. We know DDPM is denoising diffusion probabilistic model, a complicated name, but it's what it means. Just check. I had given analogy of sculpting. It is we remove the noise until we get the thing we want. So model, now instead of pipeline, we actually build the model for this use case. And you will understand how easy Diffuser's library has made even model creation. So the way it is diffusers dot the internal model used. Current architecture standard is this called as unit architecture. Okay. So it's a simple code. You understand the concept, and it's It's available as a block directly. We say how many input channels, we say how many output channels, how many layers per block we want, and what is the progression of channels, something like that. So it is a extremely amazing condensed way of allowing us to build models, because we have arrived at standard architectures. Everywhere, mostly it will be variation of those. And we use the existing weights which are trained by big companies like Google and Facebook, because they has huge data set and huge compute, and that's why we need standards. So we are using the same standard architecture, and these are the ways we can actually write that code. So it's a bit more advanced than all the lectures before. So simple model we create, and in PyTorch what we have is to define a model. You just have to create a class. What is class? Class is nothing but it groups multiple variables in one place and some important methods in one place. So multiple methods and multiple variables. So what is the architecture? We have first embedding. So we take number of classes and we build a embedding vector. And here in the neural network forward, this is what we do. We do simple. We include the class as a extra channel. Whenever we have a colored image, it is made up of RGB. A combination of these three colors, we get all infinite possible colors. So that's why RGB has three channels. Here, the class is converted into a vector of that same size as the one we have as an output of whatever, and we convert it into the size we need for the model, and we simply append it. So all of this code is just a complicated way of adding one extra channel, and that extra channel information is class. So we have RGB and class, RGB class. Okay, so that's how the model is. So this learns. We train this model on MNIST data set. This learns, and then it's the same function check. This training loop is same as every other training loop until now. So a lot of same code again and again. So once you master this code, then kind of like it becomes a lot easier to understand the change. So everything remains the same. The only difference is we can actually now, for diffusion model, we can give it this class also. So the code, it is somewhere here. The code is, look here, what kind of input image we give. We want a 28 by 28 pixel image to be generated, and we start with noise. Remember sculpting analogy, we start with the entire rock, and in iterations we remove the noise. So here with it we can give, what do I want? This is the class condition we give. So here we have just MNIST data set. If we find on Hugging Face, they have a same model available for a much bigger data set. We have a great diffusion model to work with. We can fine tune it to whatever we want. And then we have extra controllers. So this is how we think in terms of system design. This is how we can build all of these complicated solutions using diffusers library. They're all made up of these same small pieces. Okay. So here what we do is, like, if I do this print, this creates a list of a number. So and into 5 is not into 5. What it does, like 5 elements. So I want 5 images per class is what I'm saying. So and because we have 10 images, 10 class labels, we have total 50. So this is the X values for it. So we pass this to our diffusion model, and we, remove the noise. We remove the noise and we arrive at the final answer, and we'll check the output here in this code because I didn't run it. Here they wanted 8 images, so they have 80 images. So you see, 0, first row is all 0, second row is all 1. All of these images are generated by our diffusion model. And each image is generated because it was asked to generate a specific class. We have an amazing diffusion model base. If we just change a data set here, we have a very highly capable model which can be controlled, whose output can be controlled with just condition of class. In next lecture, we will see how we can, even do advanced conditioning and advanced guidance. We use text to manipulate the image. Here we just gave in a static class label. Then instead of that, we'll give text. That is what we'll see in next lecture.